Hi, welcome to Chemistry Fundamentals course. I am Mohammed Kamal, and today we are starting our journey into the fascinating world of chemistry. By the end of this course, you'll understand how the world around us works at the molecular level. So, what is chemistry? Let's begin with the fundamental question: what exactly is chemistry? Chemistry is the scientific study of matter, and I want you to think about this broadly. It is the study of matter properties, its composition, its structure, and most importantly, the changes it undergoes during chemical reactions. Let me break this down into four key components. First, matter. This is everything around us: the air you are breathing, the water you drink, your own body, even the planets in space. All of this is matter. Second, properties. These are the characteristics that help us identify and describe substance. Think of color, density, melting point. These are properties. Third, composition. This tells us what elements and compounds make up matter. For example, water is composed of hydrogen and oxygen. Fourth, structure. This is how atoms and molecules are arranged in space. The arrangement determines how substances behave. And finally, changes. This is how matter transforms from one form to another, like when iron rusts or when we cook food. Chemistry is often called the central science because it bridges physics, biology, geology, and engineering. Why study chemistry? Now you might be asking, why should I study chemistry? Let me give you four compelling reasons. First, medicine and health. Chemistry helps us understand how drugs work in the human body. Every medication you take works through chemical interactions. We develop new treatments for diseases, create diagnostic tools, and understand how your body processes nutrients, all through chemistry. Second, environmental science. Chemistry is crucial for analyzing how pollution affects ecosystems. We use chemistry to develop clean energy technologies, understand climate change, and create biodegradable materials that don't harm our environment. Third, technology and innovation. The computer or phone you are using right now. Chemistry was essential in designing those electronic chips. We create stronger, lighter materials for cars and airplanes, develop better industrial catalysts, and drive innovation in nanotechnology. Fourth, daily life applications. Chemistry is everywhere in your daily life. When you cook, you are performing chemical reactions. The cleaning products you use work through chemical interactions. Your cosmetics, food preservation, nutrition, it's all chemistry. Understanding chemistry gives you a deeper appreciation of the world around you. Chemistry, like all sciences, follows the scientific method. Let me walk you through the 6 steps. Step 1. Observation. We notice patterns or phenomena, for example, iron rust in moist air, but not in dry air. We use instruments to measure properties we can't directly observe. Step 2. Hypothesis formation. We propose a testable explanation. For our iron example, we might hypothesize water is necessary for iron to rust. The key is the hypothesis must be specific and measurable. Step 3. Experimentation. We design controlled experiments to test our hypothesis. We control variables and collect quantitative data, actual numbers, not just observations. Step 4. Data analysis. We look for patterns in our results using mathematics and statistics. We also check for experimental errors. Step 5. Conclusion. Based on our evidence, we accept, reject, or modify our hypothesis. We repeat experiments to ensure reproducibility. Step 6. Theory development. When multiple hypotheses are repeatedly confirmed, they may become part of a theory. Theories explain why things happen. For example, atomic theory explains chemical behavior. This systematic approach is what makes chemistry a reliable science. Now let's talk about some laboratory safety. Before we do any practical work, we must discuss laboratory safety. Your life literally depends on following these rules. Personal protection. Always wear safety goggles to protect your eyes from chemical splashes. Wear lab coats to protect your skin and clothing. Closed-toe shoes are mandatory. No sandals or open shoes. Some chemicals require special gloves. Chemical handling. Read all labels completely before handling any chemical. Never, ever taste chemicals. Many of them are toxic. Use fume hoods for volatile substance. Here's a critical rule. Always add acid to water, never water to acid. This prevents violent reactions. Emergency procedures. Know where all safety equipment is located. Different types of fires require different extinguishers. Have spill kits ready and know cleanup procedures. Learn basic first aid for lab accidents. Waste disposal. Never pour chemicals down drains. Separate waste streams appropriately. Follow institutional disposal guidelines. Each chemical has specific disposal requirements. Safety isn't optional, it's essential. Now let's walk you through the course roadmap. Let me outline where we are going in this course. Phase 1. Foundation building. We'll understand matter and its properties, master units and measurements, and explore atomic structure and the periodic table. Phase 2. Chemical bonding. We'll learn how atoms combine to form compounds, understand different types of chemical bonds, and predict molecular shapes. Phase 3. Chemical reactions. We write and balance chemical equations, master stoichiometry, the math of chemistry, and study different types of reactions. This foundation will prepare you for advanced studies in material science, physical chemistry, biochemistry, and organic chemistry. So today we have established what chemistry is and why it matters. We have outlined the scientific method that guides our work and the safety principles that protect us. Most importantly, we have mapped out our journey together. See you in the next lecture.